So anyway, what are the different types of uncertainty? And the three that we're talking about in this class are absolute uncertainty, relative uncertainty, and standard deviation. Okay? So what is absolute uncertainty? Absolute uncertainty is something that associates with your measurement. Example, you're measuring the mass, and the scale can read up to 3 decimal. So then the absolute uncertainty for that scale would be plus or minus 0.001 gram. Why is it 0.01? Well, because on the scale, you know, the last number seem to jump up and down quite easily, and you're not sure what number it is. Well, what does for something that is digital? For something that is digital, it's really just the last digit. Okay? Now, if something that is not digital, which means analog, so for example, a second example is volume, right? You measure the volume with a, what's that long thing equal?
Burette, yeah.
Burette, okay. So let's say you measure the volume of the titration using a burette. How do you know what is the uncertainty of the burette? Well, 2 ways you can do it. You can just look at the burette on the very top. There's a plus or minus something. A second way is that you can take the smallest division and then divide it by 2. So here's your burette, and then there's these division here. And if the smallest division is, let's say, 0.1 milliliter, then your uncertainty of that volume is whatever number plus or minus 0. Half of that, 0.5 milliliter. So this is an analog. An analog device is half of the smallest division. Cool? So that's your absolute uncertainty. The relative uncertainty, this one have to do with, this one is a percentage of your uncertainty. Your uncertainty divide by your measurement. Divide by your measurement. That's the formula. So relative uncertainty equal to the percentage of your uncertainty divided by your measurement. So example, let's say you use a burette to measure volume, right? Your uncertainty is 0.05 milliliter. So I'm calculating relative uncertainty. Your uncertainty here is 0.05 milliliter, and the number that you measure was 5 milliliter. So then 0.05 divided by 5 multiplied by 100%, that will give you the uncertainty. So how much is that? 1, 2, so that's about 1% relative uncertainty. Okay? So this means that for the smaller volume, you are going to have larger relative uncertainty than for a larger volume, isn't it?
Yeah.
So that's why when you're trying to measure, to make a very, very small concentration, you will do serial dilution, so then you can measure larger volume and reduce your error. That's come from the concept of relative uncertainty. Yeah? Okay, last one is standard deviation. So standard deviation, you probably have seen it before. On the graph, it looks kind of like this. So you have something on the x-axis, something on the y-axis, and then you have something like that, and then you have this bar graph, like so, and then on the bottom of the graph, they say something like, arrow bars show standard deviation. What does that mean? In that case, it tells you how spread out your data is.